time series to identify clouds. We studied the data from flights 7, 9, 12, 13 and 17. The flights were conducted in convective clouds by passing through the clouds at different levels, 1000, 2500, 4200, and 6000 meters. Moreover, we passed through the cloud base, 300 meters, and at surface level, 30 meters. Cloud processing signatures. Furthermore, during the flights were conducted surveys of the atmosphere's vertical profile. This information is useful because surveys have different locations, but they are associated to the cloud's recorded data. We observed changes in the properties of atmospheric particles and the processes responsible. Also, we recorded environmental and weather conditions in zones which the property changes occur more frequently, comparing both sides of the clouds. The droplets concentration in a cloud is function of the particles number in the atmosphere, so any variation in the amount of particles will affect the cloud microphysics evolution. In marine areas the concentration of particles is about 100 per cubic centimeter. If there is a greater amount of particles is likely to pollution particles are present. The EPIC 2001 research area is located approximately 800 to 1000 kilometers away from Mexico and Central America, allowing the transport of pollutants from the continent to the area when the prevailing winds are favorable. The opposite situation is also possible in maritime areas away from the coast. Wind patterns during flights 12 and 13 shows weather characteristics of maritime areas. The cloud boundaries are identified by means of videotapes taken from the plane C-130 and the analysis of time series using reference measurements obtained by the FSSB 100. The criterion was to consider the instrument's concentration records greater than or equal to 1 cm-3 obtained within the cloud. In EPIC 2001, we identified 10 cloud systems that met the minimum information necessary for the study. Table 2 shows the location, date and time of each cloud systems. The data correspond to the average information of all transects made to the system. Characteristics of cloud systems selected for the analysis. Flights 9, 12, and 13 were made on days with maritime, Mr. aerosol background and when winds came from the southwest. Higher, Hg, aerosols concentrations correspond to flights 7 and 17 with average concentrations significantly higher than the other 3 flights. Table 2 summarizes the time, location and type of cloud systems.